Hello everyone, my name is Kirolos Makar and my presentation will be about what makes carbon dioxide a greenhouse gas. Let's start with an introduction on carbon dioxide. So carbon dioxide has the chemical formula CO2. That's how CO2 looks like in a 3D shape on the top right. Carbon dioxide has a molar mass of 44.009 grams per mole. Carbon dioxide has a molecular formula of carbon, which is a solid, plus O2, which is a gas, which creates CO2, which is a gas. The electron configuration for carbon is helium 2s2 2p2, while oxygen has the configuration helium 2s2 2p4. Carbon dioxide has the melting point negative 109.3 Fahrenheit. CO2 also has the density of 1.976 grams per liter at 760 millimeters of mercury. Carbon dioxide also has a linear molecular shape and geometry. Let's dig a little deeper in what greenhouse gases are and why are they greenhouse gases. According to the United States Environmental Protection Agency, in an overview of the US greenhouse gas emissions in 2020, 79% of the greenhouse gases in the atmosphere are carbon dioxide, 11% methane, 7% nitrous oxide, and 3% fluorinated gases, and that is shown in Figure 1. For each greenhouse gas, a global warming potential (GWP) was developed to allow comparisons of the global warming impacts of different gases. Specifically, it is a measure of how much energy the emissions of 1 ton of a gas will absorb over a given period of time, relative to the emission of 1 ton of carbon dioxide. Gases with a higher GWP absorb more energy per pound emitted than gases with a lower GWP, and thus contribute more to warming Earth. Greenhouse gases could stay in the atmosphere from few years to thousands of years. When sunlight reaches Earth, the surface absorbs some of the light's energy and re-radiates it as infrared waves, which we feel as heat. These infrared waves travel up into the atmosphere and will escape back into space if unimpeded. Because some gases like oxygen and nitrogen are picky about the range of wavelengths they interact with, they do not interfere with infrared waves in the atmosphere. With CO2 and other greenhouse gases, it's different though. Carbon dioxide, for example, absorbs energy at a variety of wavelengths between 2000 and 15,000 nanometers, a range that overlaps with that of infrared energy. As CO2 soaks up in the infrared energy, it vibrates and re-emits the infrared energy back in all directions. About half of that energy goes out into space, and about half of it returns to Earth as heat, contributing to the greenhouse effect. These are some diagrams or figures that will help you visualize what I'm talking about. Figure 1 shows how Earth transforms sunlight into infrared energy. It shows how greenhouse gases like carbon dioxide and methane absorb the infrared energy, re-emitting some of it back towards Earth and some of it out into space. Figure 2 shows the wavelength of different types of energy. It shows how energy from the sun reaches Earth as mostly visible light. Earth radiates that energy as infrared waves, which has a longer, slower wavelength. Whereas oxygen and nitrogen do not respond to infrared waves, greenhouse gases do. Figure 3 shows the spectrum of greenhouse radiation. By measuring the wavelength of infrared radiation that reaches the surface, scientists know that carbon dioxide, ozone, and methane are significantly contributing to rising global temperatures. All of this is what causes climate change. Climate change is a change in temperature under typical conditions over extended periods of time. Effects of climate change include increasing sea levels, shrinking mountain glaciers, faster than normal ice melting at the poles, and altered floral blooming seasons. Climate change is a very serious topic and should be taken very seriously. To show how dangerous climate change is, many academic sources such as the United States Environmental Protection Agency and NASA are expecting flooding in coastal cities to the extent that by 2050 these coastal cities will be all covered in water. Since we understood what carbon dioxide is and what greenhouse gases are, and how does greenhouse gases absorb energy and transform it into heat, how is carbon dioxide and other greenhouse gases get emitted into the atmosphere? Despite the possibility that these weather changes are natural, human activity has been the primary cause of climate change since the 19th century. Carbon dioxide enters the atmosphere through burning fossil fuels such as coal, natural gas, and oil, solid waste, trees, and other biological materials, and also a result of certain chemical reactions, such as manufacture of cement. Other gases such as methane and nitrous oxide enter the atmosphere through land use and industrial activities, such as combustion of fossil fuels and solid waste, as well as during treatment of wastewater, the production and transport of coal, natural gas, and oil, according to the United States Environmental Protection Agency. Although that might be hard, but there are many ways to reduce the emission of greenhouse gases into the atmosphere.
Here are two other figures that would help you visualize and see what I'm talking about. In figure 1, which is on the right, it shows the CO2 in the atmosphere and annual emissions from 1750 to 2019. It shows the amount of carbon dioxide in the atmosphere, raspberry line, has increased along with the human emissions, blue line, since the start of the Industrial Revolution in 1750, which proves that human activity has been the main reason for the emission of carbon dioxide and greenhouse gases in the atmosphere. Figure 2 on the left is the 2020 carbon dioxide emission by source. As you see, transportation takes the first place by 33%, electric power takes 31%, industry takes 16%, residential and commercial takes 12%, other, which is non-fossil fuel combustion, takes 8%, and these all percents are the percents of carbon dioxide sources.
The first recommendation of reducing the emission of greenhouse gases is chemical refrigerants. Chemical refrigerants, which retain and transmit heat, are used in every refrigerator, grocery store, and air conditioner to chill structures, cool cars, and preserve food. There are currently HFC replacements available on the market, including natural refrigerants like ammonia and propane. The second recommendation is reduced food waste. Each year, 4.4 gigatons of CO2 are released into the environment as a result of the food we waste. Therefore, we should all reduce food waste and everywhere around the world, improving infrastructure for storage, processing, and transportation is essential. The U.S. Department of Agriculture explains that saying, production, transportation, and handling of food generate significant carbon dioxide emission, and when food ends up in landfills, it generates methane and even more potent greenhouse gases. The third recommendation for reducing the emission of greenhouse gases into the atmosphere is plant-rich diet. I know this might be surprising, but raising livestock holds account for 15% of the global greenhouse gases emitted each year. The National Library of Medicine explains, moving to diets that exclude animal products could reduce global GHG emissions by 49%. Therefore, I think we should all move to plant-rich diets. The third recommendation is very, very important. When forests are destroyed, carbon dioxide gets emitted into the atmosphere. In addition, plants absorb atmospheric carbon dioxide. According to the Center for Science Education, through the process of photosynthesis, carbon dioxide is pulled from the air to produce food made from carbon for plant growth. That happens through the carbon cycle. That means that the plants and trees have a great function of removing carbon dioxide from the atmosphere. Therefore, wildfires and deforestation stand in the way of solving climate change. Accordingly, the restoration of forests would remove a great amount of carbon dioxide and other greenhouse gases from the atmosphere.
Here are the two pages of references. I used articles or studies from the United States Environmental Protection Agency, Center for Science Education, NASA, Climate Action, USDA, U.S. National Library of Medicine, and Columbia Climate School.